Paul, thank you very much for joining us here on AU Manufacturing Conversations. It's very good to have you on the program.
Great, thanks, Brent. Nice to talk to you.
First question for you, as it is for all our guests, is how did you get here and what do you make?
Well, I guess our history started, actually, and probably fairly similar to my career path as well. We actually started as a cooperative research centre. So that program, which still runs today, commenced in 1991. A CRC for what was called aerospace structures was first established back then, and that morphed into the CRC for advanced composite structures about 7 years in. It was able to successfully continue to get funding. So it was basically a program bringing the research users and the research providers together as a consortium. We ran that program through to, in the end, 2015. But in 2010, we made the decision to actually, spin out a company, which could be, an ongoing entity after the life of the CRC. So in 2010, we set up ACS Australia, or Advanced Composite Structures Australia. We transferred staff across to that entity, and for the first 5 years of its life, it ran the CRC program, the last 5 years of that program. And in parallel to that, then started to develop a commercial business in which we were able to provide those types of services, that type of development work that we're doing within the CRC as a commercial entity on a fee-for-service basis. A key part of doing that was that we were able to capture the intellectual capital and property from that CRC. We were able to retain a large proportion of staff. And so today we're a company now which basically does similar to what that CRC did, except as well as doing the engineering services type work that we do, with a sole focus on using composite materials and structures, we've also expanded that to now do series manufacture for our customers. We're not what you'd call a build-to-print company, but we do manufacture products that we develop for our customers.
To do with that question, I'd like to know a little bit more about you personally. I had a bit of a snoop of your LinkedIn, as people do nowadays before they speak to each other, and it looks like your career has progressed more or less in parallel with the organisation, and you've sort of been in composite/aerospace engineering for just about all of it. Tell me about your professional and academic background, please.
Yeah, so I did a Bachelor of Engineering in Aerospace, which led to my graduation back in 1991. The employment market those days wasn't so great, and a few of us actually decided to do a PhD. PhDs weren't such a popular thing back then as they are today, and so I ended up doing a PhD through what at that time was a CRC for aerospace structures, a fairly foreign new thing to me. So I did a PhD which spanned about 3.5 years. As part of that, the CRC gave me the opportunity to spend some of that time in the US, so I did 9 months at the University of Delaware as part of my PhD, which was a great opportunity. At the end of that PhD, I then was able to get a research engineer position in the CRC, which basically began around 1994 or so. And then through that time, my role had evolved. It went from being just a junior engineer to a senior engineer. The diversity of the work we do means that your job is always changing and evolving, to a point where I then sort of transitioned into sort of managing large projects, and then eventually stepping away from the hands-on side and looking at the business side of what we were doing, and took on the role as what we called business manager at the time. At that point, back around 2010, we did a transition of the company to form ACS Australia. I then from there transitioned to become eventually the general manager, which I am today, and I've held that position for about 8 years now. So I still get pretty excited on the work we do, very excited on the work we do. Unfortunately, I don't really get a chance to get my hands dirty these days, but at least I get to see what we do, and from an idea on a piece of paper through to something physically that we manufacture and can deliver to a customer, and be able to make our customers happy.
So tell me about the size of the company, please. What have you grown to, and what sort of skills are involved? I imagine many kinds of engineering disciplines and probably some trades, but I'm purely guessing, as I've never visited your factory. Tell me about that.
So current headcount, it sort of can fluctuate a little bit, but we've got about 25 people at the moment. We've got a range of skill sets with our personnel. So we have a number of engineers who either have a materials background, an aerospace engineering background, or a mechanical engineering background traditionally. So we have those, and they've got a broad range of skill sets, from having expertise in, say, the manufacturing, maybe a bit of automation. There's we have expertise in materials side, and then we have those who are fairly, their areas of expertise are in the simulation and modelling and structural analysis side. So that covers all those areas. And obviously from our being able to manufacture these things, we've got some engineers who are quite hands-on, but we also have a number of composites technicians as well who basically have trade backgrounds, and they may have like an aerospace, like we call a LAME, a licensed aircraft mechanic background, or we've got some boat builders or prior boat builders, or those who've come from, again, aerospace engineering, manufacturing background.
To go a little further with what ACS does, so I'd like to know about the current focus around each of those initials, what's advanced, what's being done with composites, and what sort of structures are you making?
So in terms of advanced, we work with composite materials, but we like to emphasise we work with advanced composite materials. So the stuff we do is fairly high-end, fairly niche and specialised. But as well as on the manufacturing side, the engineering that we do, the simulation work we do is highly advanced. So we have a lot of expertise in what we call dynamic modelling. So we can model things such as bird strike events, crash events, impacting bodies, something hitting something else. So as well as doing the more, routine structural analysis of structures to determine, what load they can carry and ensuring they're going to be stiff enough and rigid enough, we can also do that very high-end, advanced simulation as well. In terms of composites, we work across a whole broad range of those materials. So, a lot of the work we do is using carbon fibre in our structures, but when it makes sense, we're using glass reinforcements as well, or we may be looking at other material formats. In the high temperature work we're doing, we're starting to bring in some more exotic materials. The resins themselves start to play a really key part of the material. So typically we look at things like epoxies and vinyl esters if we're looking at, say, the aerospace or the marine industry. And once we start getting into the high temperature space, we're talking about ceramics. We're looking at phenolics and the like in terms of, the composite and material side. And in terms of structures, we basically design typically structures where light weighting is required, or it's, an application where traditional materials, as in metals and so on, won't work. And so we developed a structural design using composite materials. And at times, these solutions can be quite unique. And great examples of that is the work we're doing right now in the renewable energy space with companies like Carnegie Clean Energy, where we're developing some unique structures there to meet their requirements for their applications.
Right, they're around wave energy, right?
Yeah, exactly. Yeah, they've got a wave energy technology that they've been developing, has some great potential, and they've had some aspects of the technology which they're trying to improve, and that's where our expertise in composite materials and structures comes in to help address those aspects and to improve what they're trying to do.
Mentioned ceramics and ultra high temperatures, and yesterday, it's probably not going to be timely when this is out, but yesterday, as of when we're speaking, there was an announcement that Hypersonics had brought in a fancy ceramic matrix ultra high temperature resistant version of their scramjet from overseas, and obviously that's a very sexy piece of equipment, and there's a lot of interest in Australia developing the capabilities to produce such things. I mention that just so I can lead you into talking about what you do in terms of hypersonics and what you're tooling up to do in the future. Let me know about that work, please.
Yeah, look, we've been working in the area of ultra-high temperature composite materials for almost 3 years now. So we're working closely with the Defence Science Technology Group, and what we're focused on here is basically developing sovereign capability whereby we can process materials which can be used in high temperature applications, so in hypersonics, or it might be in re-entry vehicles, in componentry for rockets and so on. And that process really involves traditionally producing what we call a green body. So it's really a composite structure that's manufactured using more of a conventional process, and then it gets converted into a carbon-carbon or ceramic, carbon material, and that requires a pyrolysis type process. And so we've developed a capability on the green body side and have developed our technology in the pyrolysis processing side. So, and with the new investments we've made, that's now capability that we can deliver in-house.
Let's turn to another thing I'm curious about. A couple of the other nominees for our Most Innovative series have submitted work or are currently doing work around composite pressure vessels for storing renewable fuels like hydrogen. Is this an area of interest for you guys, or is it peripheral to what you do?
Oh, look, it is. We actually just completed a project with one of the universities, which was looking at developing it was actually a test system for a technology that they're working on, which is looking at more efficient storage of hydrogen. And their technology is really looking at what they call the use of MOFs or metal organic frameworks in order to improve the efficiency. So we've worked with them to develop basically a test system to enable them to evaluate their technology that they're developing. So basically our first step into working in the hydrogen space, but we're keen to continue that development and building that capability in-house. We are in the process, we have acquired a filament winder, which is going to be utilised predominantly for our hypersonics work that we're doing, but we'll also be able to feed into looking at things like pressure vessels and other structures of revolution.
So the next thing I'd like to ask about is your personal and/or company definition of innovation. You guys are obviously part of our Australia's 50 Most Innovative Manufacturers campaign, and I'm grateful you took the time to apply and to be a part of this. Your answer, please.
To us, innovation means really finding new ways to design and manufacture advanced composite structures in order to meet unique demands from the market. A lot of our solutions to problems can be quite bespoke and quite challenging, and we do have a reputation for, solving complex problems for our customers. And to us, innovation really is about then pushing the boundaries and always looking at new opportunities, growth and improvement of our team members. And we've got a culture where we try to foster creativity and collaboration amongst our staff. The other aspect, to innovation as well is we're always looking at, trying to not necessarily accept what can't be done, really to understand why it can't be done, and is there a way to try to overcome that problem and develop a solution around that, really trying to think outside the square.
To stay with your nomination a little while longer, you mentioned the Lorimer Composites Innovation Program as part of your initiatives. Tell me about its role in developing new products, what goes on, and anything you'd like the audience to know about it.
As a company, we primarily develop products for other customers. So they come with their problem, we help them develop that product, we then offer to manufacture that product for them. But as a company, we're also looking at developing capability, looking at developing a suite of products that we can sell to the market as well. And so the Lorimer Composites is really an alternate brand, which enables us to look at exploring other ideas which maybe would probably provide confusion if it was associated with the Advanced Composite Structures brand or company. And so there we're looking at trying to foster, innovation with both internally as well as externally, where we're open to having people come to us with some ideas, usually with a focus on composite materials, and then for them to pitch that idea and see whether that's something we think has merit. If it does, we're then happy to look at exploring a way of trying to invest with them and to develop that idea, utilising the people we have here and the infrastructure that we have. So we have piloted the program. So we ran through a trial just to see how it might work. And the way this works is the staff do this in their own time. We co-invest, and then any, benefits or any commercialisation that we can achieve from that, they'll get a share of that. So we tried out the program. We looked at developing a product for the consumer market. So we did something in-house, developed that, put it to market. It wasn't overly successful, but it did, develop a lot of learnings for us. We saw that the idea and developing the idea is probably the easy part of the process. And the more challenging part is really getting it out there, getting it known, and then, establishing that demand for the product. But yeah, it was a worthwhile exercise, and we're really looking at, open to people coming to us and pitching their ideas and see how we can work with them to make it happen.
It might not be the intention, but like any other company with a lot of bright engineers, it probably helps keep them engaged and probably is an incentive to stay there and not take their new idea into a startup, perhaps.
Yeah, absolutely. We try to create an environment here, which is one where people come, obviously you still need to pay them, but they come for the enjoyment as well. So we've created an environment here where it allows people to be creative, put forward their ideas, whether it's to solve a customer's problem or potentially to pitch an idea that they think has merit. And so we definitely promote that type of culture here in the company.
Another thing I'm curious about, sometimes I hear people talk about Australia's lack of ability to make certain things and dependence on certain countries to buy in certain feedstocks. I'd like to get your point of view, please, on reliance of imported raw materials for composite making. Is this a limitation for you guys, and do you have any sort of reservations about security of supply or any other issue related to this?
I think definitely there are certain raw materials that we use which, I guess, readily available through local supply. Now, those materials may have an origin back to overseas. An example might be, say, glass fibre reinforcements, which can be locally sourced through local suppliers who manufacture those fabrics, but the raw fibres themselves are most likely sourced from overseas. Those sorts of materials aren't so problematic. When we start to look at more exotic materials, say some of the materials we're using in aerospace applications, or for instance, in some of the work we're now doing in the ultra-high temperature space, those materials unfortunately can only be sourced from overseas, and so there is a reliance on those suppliers. And if there's only a single supply of that, then obviously there's risk associated with it. We are always, particularly in the work we're doing in the ultra-high temperature space, we are looking at and trying to engage with local suppliers who can procure and produce the resin systems that we're using, or even some of the reinforcements that we're using. So we are always trying to, I guess, address that aspect. Also, some of the work we're now doing in the defence space is not demanding, but would much prefer those materials to be sourced from local markets, or at least from markets not from particular jurisdictions.
Lastly, a stock question for this series, and one I'd like to ask people in general, is what's one issue within manufacturing that isn't getting the attention it deserves at the moment?
From our perspective, what we're finding is that there's been a push now for onshoring work again, onshoring manufacturing, requiring the ability to manufacture these products and so on here in Australia. I guess the issue with that is that in order to do that, we still need to try to be as price competitive as we can. But we're in an environment whereby costs all across the board are on the increase. We've got large companies out there paying their employees significant amounts of money, so to retain capability and staff is really challenging in the manufacturing space, and then trying to then find or attract people with the right skill sets we're finding is becoming problematic for us, and I think that's really one of the main concerns we have.
Okay, Paul, well, that's everything I wanted to ask you, so thanks very much for donating your time to this appearance on AU Manufacturing Conversations. It was lovely to meet you.
Great, well thanks for that, Brent.